Good afternoon, dear all colleagues. The war has forced Ukraine to fundamentally rethink the architecture of its energy system. Since the first massive attacks on energy infrastructure in late 2022, distribution generation has become one of the central pillars of the country's strategy for energy resilience. It is widely viewed as the fastest and most flexible way to compensate for the significant loss of the generation capacity caused by the war. In response, the government of Ukraine has simplified permitting procedures for distributed power plants and introduced regulatory and fiscal incentives to accelerate their deployment. Ukraine has also received hundreds of generation units as international technical assistance. However, experience over the past 2 years has clearly demonstrated that deploying distributed generation is far more complex than simply delivering equipment. Even during the extremely cold days of February this year, for example, when many consumers experienced electricity shortages of up to 12 hours per day, the average utilization rate of this installation remained at only around 28%. This reflects several structural challenges, including insufficiently prepared sites, limited financing for installation and grid integration, shortages of qualified personnel, and technological constraints with distribution networks. Therefore, the key challenge today is not simply installing more equipment, but developing well-prepared, scalable, and financially viable distributed generation projects. Consider that Ukraine may need to deploy 5 to 7 gigawatts of distributed capacity in the coming years. The energy sector requires projects capable of combining technical reliability with investment attractiveness. Please start presentation, slide 1. One such project is a distributed cogeneration platform currently being developed in the city of Bucha. Because Bucha and Kyiv share the same high voltage transmission nodes, strengthening generation capacity in Bucha directly contributes to the stability of the wider Kyiv metropolitan energy system. Importantly, this project is not conceived as an emergency solution. It is designed as a long-term distributed and grid-integrated energy platform aimed at attracting private investment. The project is supported by a completed preliminary feasibility study prepared in accordance with the methodology of World Bank applied by Ministry of Economy of Ukraine. The study includes technical configuration, phased implementation, financial modeling under different regulatory scenarios, and sensitivity analysis including the impact of gas price fluctuations. Preliminary technical conditions for grid and gas connections have already been coordinated with the regional electricity distribution operator, the regional gas network operator, and the gas transmission system operator of Ukraine. In addition, construction of 10 to 110 kilovolt substation already financed by the government of France for second stage of the project. This significantly reduced grid integration risks. Next slide. The platform is planned in 2 phases. The first phase includes 49 megawatts of combined heat and power capacity with a planned construction period of approximately 12 months after signing the EPC contract. The second phase adds 64 megawatts, bringing total generation capacity to 113 megawatts, complemented by 30 megawatts of energy storage. Natural gas will serve as a primary fuel source. Phase 2 will connect to a main pipeline located approximately 1 kilometer from the site, while Phase 1 facilities will connect to existing medium pressure gas distribution networks. This configuration enables highly efficient combined heat and power production, reduction of transmission losses, peak load balancing, participation in ancillary services, and diversification of revenue streams. During the preliminary feasibility stage, a comparative analysis of available technologies identified Wärtsilä as one of the leading solution providers in this segment, with potential technical support through its WFTS program. Next slide. The project also introduces several important technical capabilities that many existing installations currently lack. First, the 113 megawatts of capacity fully covered the electricity needs of the community and nearby industrial clusters. Second, the system is designed to participate in all types of ancillary services, supporting the stability of the wider power system. Finally, the platform is designed for high operational resilience and includes an autonomous operation capability, automatic grid reconnection, island mode operation, and black start functionality, which allows rapid restoration of power after major system failures. Next slide. The total expected investment in the project is approximately 145 million euros. The assumed capital structure includes 50% equity and 85% debt financing. The project demonstrates strong financial indicators and expected payback period of around 7 years with other good financial. Next slide. In addition to its technical and financial viability, the project will also generate significant socio-economic benefits. Reliable and uninterrupted energy supply will be provided to approximately 28,000 households, as well as 90 healthcare facilities and 29 educational institutions. The project will also support the development of 5 industrial clusters covering around 3,400 hectares, expected to host more than 100 enterprises in logistics, medical services, IT, and manufacturing sectors. These developments will create thousands of jobs for residents of Bucha, Irpin, and Hostomel, including internally displaced persons from eastern Ukraine. All facilities will comply with European environmental standards and the National Emission Reduction Plan. Closed-loop water management systems are also envisaged to minimize environmental impact. In conclusion, the project has been designed with strong attention to risk mitigation. From an investor perspective, key factors include the completed feasibility study, coordinated grid and gas connection, ongoing construction of the required substation, distributed multi-site architecture, efficient CHP technology, integration of energy storage system, the possibility of war risk insurance mechanism, and public-private partnership framework supported by the municipality. Together, these elements significantly reduce implementation and integration risk compared to a stand-alone project developed from scratch. The Bucha distributed cogeneration platform demonstrates how resilient energy infrastructure can be developed even under extremely challenging conditions. Our objective is not only to strengthen the energy security of Bucha and the Kyiv region, but also to create a scalable model for distributed generation projects across Ukraine. We therefore welcome cooperation with financial institutions, technology partners, and strategic investors interested in supporting Ukraine's energy resilience and recovery. Thank you for your attention.